Question 1, given the function for the absolute value of x, let's look at part A here. What is the domain? Domain is going to be how far left and right the graph travels. So we want to open up our calculator here, and we're going to type in that equation, absolute value of x. And so if you split this up in the middle, if I look on the left-hand side, and there's actually an arrow on the left because as I zoom out, you see that it keeps going all the way to the left forever, and it's going all the way to the right forever. So if you have arrows on the left and you have arrows on the right, that means the domain is going to be all real numbers, or you could write it as negative infinity to positive infinity. The axis of symmetry, it's going to be an x equals equation, and that is where it crosses the graph or splits the graph right down the middle. So if I were to ask you where does this split the graph down the middle, it splits it right at 0 on that x-axis. So our axis of symmetry is x equals 0. The range is how far down and up the graph travels. Let's go back to our graph. So we always start with how low the graph travels. If you look right here, the lowest that it goes is at 0 on the y. But then if I look up top, I have arrows pointing up. Our range starts at 0 and it goes up forever. 0 is going to get a bracket because it is part of the graph. What do you notice about the x and y intercepts? That is where the graph crosses the x-axis and the y-axis. If I go back to my graph here, you'll see that right at the vertex is at the origin. The origin is the x-intercept, and it's also the y-intercept. So that means both the x and the y-intercepts are 0, 0. Or you could say it crosses the x-axis at 0, and it crosses the y-axis at 0. What is the coordinate for the minimum vertex? That is going to be the lowest point of the graph. Well, we know that that coordinate is 0, 0, but if I wanted to calculate it, you could go menu, analyze graph, it's a minimum, and then you just shade, and you can see right there it tells me the coordinate of that minimum vertex. It's 0, 0. Here we go, so we can say 0, 0. Let's look at question 2. If A and B are x-intercepts, that means A is an x-intercept and B is an x-intercept. That's where the graph crosses the x-axis. They want to know what's the value of A plus B. We want to add where the graph crosses the x-axis here together. Anytime they give you an equation like this, we're going to put that in the calculator. Let's get rid of some of these background pages here. So let's graph our new equation. So we're going to go new graphs. So we'll create a fraction here. You can say 1/2. You could also use 0.5 if you wanted to. So 1/2, the absolute value of x plus 2 is in the house. And then we do -3. So now what we're going to do is we're going to look and see where it crosses the x-axis here. And if you don't see the x-intercepts, you might have to zoom out. We can see them here. So if I look on the right, I go 1, 2, 3, 4 to the right. So I have an x-intercept at +4. And then if I go 1, 2, 3, 4, 5, 6, 7, 8 to the left. So I have one at -8. So let's look at our problem here. It's asking us to do A plus B. Just add them together. -8 plus 4. Well, that would be -4. All right, let's look at the next problem here. 3. The parent function, which is the absolute value of x, has a vertical reflection shifted horizontally 6 units to the right and shifted 4 units down. We are going to use this transformed equation here with A, H, and K. Now, when you're taking your test, they're probably going to give you multiple choice, A, B, C, and D, and you can take each one of those, graph it, and see which one has a vertical reflection over the x-axis. That means it's going to flip down. It's shifted 6 units to the right and 4 units down. When you find that graph, you'll have your answer. But for this problem, we're going to write the equation. The vertical reflection is going to be the negative value for A. X stays in the house. When you shift 6 units to the right, remember H is a liar. So if I want to shift 6 units to the right, I'm actually going to do minus 6 in the house. And k is the movement up and down. So 4 units down would be minus 4. This would be the equation that we would use. Now what we want to do is we want to write the range for this transformed equation. Here we go. New graphs. New graphs. And then we go negative absolute value of x minus 6. And it was minus 4. So let's see. Did it flip upside down? Yes. Did it move 6 units to the right? 1, 2, 3, 4, 5, 6. Yes. Did it move 4 units down? Yes. So now we have arrows pointing down. When we write the range, it's how low and how high the graph travels. Well, if I have arrows on the bottom, that means that my range is starting down here at negative infinity. But if you count on the y-axis how far up it goes, it only goes up to negative 4, kind of right there where that pin pop-up is. And to write that in interval notation, we say it starts at negative infinity. Remember, we always go from least to greatest. And then it stops at negative 4, and negative 4 will get a bracket because it's part of the graph. All right. What is the first step in solving this equation below? The house is by itself. That means you drop the house and you just do the equals 3 equals negative 3. And so that would be B. That one's pretty simple. So when the house is by itself, we know drop the house, do the negative and positive version on both sides. 5, we need to solve this and then graph it. So the house is already by itself. Since the house is by itself, we can drop the house. 2x minus 1 equals, greater than 11. And then we have to use the symbol going in the same direction. And then we're going to use minus 11. We're going to solve this simultaneously here. So we're add 1 to everybody. That cancels. Add 1, add 1. That leaves us with 2x in the middle, 12 on the right, negative 10 on the left. Divide by 2, because we're doing opposites. Divide by 2, divide by 2. So we have negative 5, x, and then 6. Because this is a more than or greater than, remember, more is or. And that means they're going to go either to the left or to the right. And we want to split this up. Let's rewrite that. Look at where the arrow of the little symbol is pointing. The little arrowhead is pointing towards the x. So when you rewrite that, you should have the symbol pointing toward the x like it is, or the alligator mouth is eating the negative 5. Excuse me. And then this one's already done for us. Or x is greater than 6. And then how does the shading work? Well, if you wanted to, knowing that more is or, you could just find negative 5. It's an open circle, right? Because there's not an equal sign. And or more is or. That means this one goes to the left. And then 6 is an open circle. And that is going to go to the right. So you don't have to split it up necessarily. Because if you know more is or, it's going to go in 2 different directions. 6, what is the negative solution for the equation below? We need to get the house by itself, so let's divide by 3. Divide by 3. 2y plus 5 equals 9. Now that the house is by itself, you can drop the house. Equals 9 equals negative 9. Here we go. We'll solve this simultaneously. Let's subtract 5, because we always start with add and subtract. Negative 14 on the left, 2y in the middle, 4 on the right. Our last step is to divide by 2, since we're doing opposites. And when you do that, you have negative 7 is equal to x, which is equal to 2. That's telling us we have 2 answers. X is equal to negative 7, and x is equal to 2. All right. Which describes the transformation below? Well, I'll tell you this. When you plot your parent function For the absolute value, it is over 1 up 1, over 2 up 2, over 3 up 3, over 1 up 1, over 2 up 2, right? This one is not over 1 up 1, over 2 up 2. This one is over 1 up 2 immediately. That tells me it's stretched. And you can see from my purple graph, compared to the one that's graphed on the left, you can see that the one on the left is stretched. So we know it vertically stretched. And it shifted to the left. Well, when you shift to the left, that is horizontal movement. So vertically stretched and horizontal movement. All right. 8. When you're writing absolute value equations, you want to find the main part of the problem first, and you want to put the variance or what's changing on the outside. So you have a 54-ounce bag of rice, and it's changing as much as 0.2 pounds. So the variance, which I circled, is going to go on the outside. Remember, it's always x minus 54. Put the variance on the outside. 9, what is the solution? The house is by itself, so we drop the house. So we do 24, make your symbol going in the same direction. Excuse me. All right, here we go. Allergies are getting me. Add 6, add 6, add 6. Come off to the side here. We're going to have negative 18, 2x, and then 30. Divide by 2, divide by 2, divide by 2. So we have negative 9 is less than x is less than 15. If I were graphing this, I would say less is nest, which means we would go from negative 9 to 15. They would both be open circles, and we would nest that. But it's just asking us to solve it, so we can leave it like that. All right, one more here. What are the solutions to the equation below? The house is not by itself, which means we need to get rid of the 2. Do opposites, add 2. Now we have 3x minus 5. The absolute value of that is 5. I'm sorry, 3x minus 5. Let me try that again. The absolute value of 3x minus 5 equals 5. Now we can drop the house. We go equals 5 equals negative 5. Start in the middle. We're going to add 5. Remember, you always start with add or subtract. So that gives us 0 on the left, 3x in the middle, 10 on the right. Divide by 3, divide by 3, divide by 3. 0 divided by 3 is going to be 0. 10 divided by 3, you can leave it as a fraction, or if you put that in the calculator and you convert it to a decimal, it's 3.3 repeating. So either way, it doesn't matter.